Okay, my wonderful, outstanding, intelligent, scientific friends, we know that the Bohr model did not work from day one. It's boring. Now, what is there? Well, there's a new, and I say new, 6 years now in its completed form, electron flood theory. And what is electron flood theory? It says that there is nothing in the universe that exists except electrons. And you say, well, how could that be? That means that everything's going to turn into lightning. No. Electrons make everything. They can be separated and turn into electricity, but when they are in mass, they are molecules. Now, here's the way it works. CERN has seen these little black particles called muons. They just show up in all the debris that they're looking through. Because when they explode things, they explode millions. We explode two particles. And we can actually see these exact particles. We see that exact shape. And then we see these particles disassociate from each other. And I'll show you in a second. So this is an electron. And that electron is a bar magnet. That bar magnet has a field surrounding it. When it as an electron goes through a wire, it pushes all the other electrons and it forces them. And whenever an electron pushes another electron, I call it push to shove, it causes glow and an expanded amount of energy. And we can create an amount of energy you won't even believe. The photon is two electrons back to back. That will burn you into you to try to associate with another electron. This is a completed sort of a neutral particle, but it's a photon. It's light. It will bounce off of you. And depending upon what it hits and how hard it is and what it was emitted from will depend on what color you see. Because we can only see in a very narrow margin of the spectrum. That's another whole issue. But when we get into protons and molecules, every single thing there is, 100% of everything, is painted with electrons, the powerful part, around a black center, which is the attractive core. Now, when they're in there, these really disassociated little bitty pieces, photons and electrons, you see them in this. But I will also be able to show you in this form. So let's start our discussion. Now, Ben from Applied, I think it's Applied Science. Absolutely fabulous guy. However, Ben, you got a problem, buddy. Applied Science. I went into this Crookes radiometer because I understand how it works now, and nobody else does. If somebody else can deny what I'm saying, I want to know why. And we're going to get deep. It's going to take a little while to show this. Ben is absolutely fabulous. This guy's he must have been really good as a kid because Santa Claus has been real good to him. His toy box is loaded. Now, where do you see this? Here goes. Ben, I love your brother, but you're wrong this time.
If you've been to the gift shop at a science museum, you've probably seen one of these. This is a Crookes radiometer, and it works like this. If we shine light on it, the radiometer starts to spin, and the brighter the light, the quicker it spins. But what actually makes it spin? You might be tempted to think that it has something to do with the photons themselves. So the photons that are emitted by the light bulb hit the radiometer, and it's actually the momentum of the photons that cause it to spin. However, look more closely. As you can see, it's actually the black face that's trailing, meaning that there's more force on the black face than there is on the white face.
And that's exactly what would happen. The black face is absorbing electrons. Electrons are nothing but little magnetic fields. As those photons, magnetic electrons, push their way in, more of them stack up behind it, and it creates more and more force against it. It's as simple as that. These they bounce off. Now, I can prove this to Ben because he took this apart and he did some really fancy stuff. But I was trying to say to myself, how could I prove it to him? If this was painted with photoluminescent paint, you know, like day glow paint, you shine a light on it and it gets bright, and I saw a guy take that luminescent paint and in the dark shine it into it, and then you can see it sort of dissipate slowly. The light comes out of it. So what that means is the light is being emitted from it slowly. So it absorbed it, and then it just let it fall off slowly, which is perfect, exactly what I want. If he painted this with that kind of paint, I say this side would go, not that side, even though it's black. Now the black, it might not go at all, because this is absorbing all the light, and that means as it absorbs the balls, they keep stacking up on top of each other, which means pushing, pushing, pushing. So you understand the concept. Now the same thing's going to happen here if he put this photoluminescent paint. It would suck the particles in, just like this is heat, and then they would back up and back up and back up. So this would be sort of a push to shove. I'm not sure which one would go, but I can tell you what, if he did it with just the white and the black with a light, it would go like, say, 50 RPMs. If he painted it the way I'm talking, it might go 10 RPMs, but it's not going to go as fast as it would if this wasn't absorbing electrons, and they think it's just the opposite. So Ben, I think I got a way for you to test this. But watch what Ben has to say. I love the guy. Just listen.
Of the radiometer vanes. Now, if we think about the photons coming out of here, they would actually be reflected off the white sides and absorbed on the black sides. So that would mean that they're actually delivering more force to the white faces, and it would cause it to spin the other way.
See, that's just wrong. It's just wrong-headed thinking. As the black side keeps getting bigger and bigger and bigger and bigger, you can bang, 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 bang. You're pushing harder and harder and harder. This one here, they just bounce out of the way. They just get out of the way. This one, they sort of accumulate and give you a bigger smack against it. And that's what I want them to do on this side with the photoluminescent.
So the explanation that light pressure causes this radiometer to spin is actually completely wrong. It would spin the other way if it were true.
All right, Ben, we're going to find out, buddy. You're the kind of guy that does these experiments. Absolutely fabulous work. I am not disparaging you in the slightest, brother.
Now, there is such a thing as light pressure. It's a very, very small effect. Something like a 50-watt laser produces maybe about 17 micrograms force of pressure, of force on a vane like this. And the amount of force that's being generated inside there is actually much higher that causes it to spin. So there must be some other explanation for its movement. So let's try something else. I've let the radiometer come to rest by itself.
All right, now I'm going to talk to you about this. This is where I decided I had to intervene and make a video about this, because what he's going to do is spray a spot on here, extreme cold, and then it's going to go reverse, and that is fully understandable, because the cold heat pushes electrons, cold sucks electrons in. The electrons are still flooded onto that surface much more than they are on the white. So even though he's let it come to rest, it still has a ton more of electrons that want to come to that cold. That's why it spins backwards. So I'm prepping you. Here it goes. I'm sorry, Ben. I love you, brother.
I'm going to spray some of this on it. This is canned air dust.
Now, here's what I want you to do for this one. Set it in a dark area for 24 hours, and then do the duster on there right away before it gets much light on there, and then see what happens to it. I would say it won't go backwards.
Which is actually a refrigerant, and what I'm going to do is tip it upside down and spray some of the refrigerant on the glass envelope of the radiometer. And as you can see, it's actually spinning backwards relative to the way that it was spinning when we shined the light bulb on it. So clearly there is something else.
All right, this also works perfectly for my electron flood theory. We know that the black particles suck the white particles back in. These black muon dark matter particles are extreme attractors to electrons. That is exactly what is happening here. Cold has a lack of explosive particles. And it wants explosive particles. That's why cold wants heat to flow into it. Heat wants, that's why they balance each other out. Let's just go with that. So it's trying to balance. And it's going to pull as many electrons as it can away from the black. And the white has nothing to give up. So it keeps pulling these away, and they just keep coming at it.
What's going on here, if it were just a photon effect, making the glass envelope cold would not cause it to spin backwards, because we aren't pulling photons out that way.
Well, you are actually, Ben. And like I said, give it 24 hours in a totally dark spot that no light can warm up that black, and I say it won't spin backwards.
As you might have guessed, the effect is thermal, and it does require that there be some gas in the radiometer envelope. If there were no gas at all inside here, then the only thing that could touch the rotor and make it spin would be the photons shining on it. And we've determined that can't be right, because the photons would be making it spin the other way.
All right, so far he's making assumptions that aren't right, and this is what I always see. But I still love you, brother.
We also know that it doesn't work if we're just at ambient pressure. So if we just broke this glass envelope and shined light on this, it wouldn't spin. The gift stores would be unhappy because they wouldn't be able to sell you this neat little glass envelope. So that means that there must be some ideal pressure at which the thing works really well. It can't be zero, and it can't be ambient pressure. So I've set up my vacuum chamber here with a vacuum gauge, and the radiometer, I actually broke one of these open and took the rotor out and set it up on a pin inside there. And I have a tachometer set up so we can measure how fast the radiometer is spinning. And we can also adjust the pressure in the chamber to figure out what the ideal pressure is to get it to spin the fastest. And this will give us another clue as to the mechanism that actually makes it spin. This vacuum chamber has two vacuum pumps, a mechanical pump and a turbomolecular pump, to bring the pressures down to very low levels. Both vacuum pumps are now running, and I've pulled out as much air as I can from the chamber. So now I'm going to turn on this directional spotlight. And as you can see, nothing's happening. The rotor is not spinning. And you might be saying, well, it's just because the light level isn't high enough. But from previously playing with this, I know that this level of light is more than enough to make it spin. The fact is that there's just so few gas molecules in the vacuum chamber that we don't get this thermal effect, and there's nothing to make the rotor spin.
I can agree with that. I have no problem with that, because what it has to do is stack up a bunch of molecules behind the light coming in, which I probably have shown you, or I certainly will show you, is the Venturi effect, but it's just in the air. But I can show you it concentrated through the Venturi, and it'll make a little more sense. Here goes. He's going to add some air.
I'm going to raise the chamber pressure slowly by opening an electronic valve.
It's just opening just regular air, nothing special, I guess.
As you can see, it's now spinning. I can measure the exact rotational speed with the optical tachometer that's inside the vacuum chamber and get the readout from the oscilloscope here. And also the voltage listed here is the vacuum level, and it's also displayed on this panel.
Look at the toys this guy's got. Now, I had a dual trace oscilloscope. I had all kinds of stuff, but nothing like this. Of course, this is 30 years ago. 40 years ago. But, boy, I had a ton of fun trying to understand. I was a field engineering manager for a global company, Victor Business Products. And when they first came out with the electronic machines, that's when they hired me to troubleshoot the problems when they hit the field. And, man, they had all kinds of problems. And it was almost all related to static discharge. Static discharge is what happens when you accumulate electrons on you in the air in dry conditions, and then you discharge them to something. These electronic circuits were not isolated enough from these electronic explosions, literally. And I did all kinds of stuff, engineered all kinds of things, and we finally figured it out and fixed it. But there was a time there that they were throwing the computers out of windows. You walk up to the computer, I got to tell you, this is hysterical. This just came back to me. a huge grocery store chain was one of the first ones to put in the electronic machines, and there were 7 machines. And it was a big deal. Oh, it was in the news and everything else. And the machines go in there, and we had them all tested out and ready to go. We installed them. They get in there, and boom, I got a call. They got a machine down over at the supermarket. So I said, oh boy, I shoot over there. Yep, sure enough, the machine is what they had. Its thing that said re-enter, which means that something is wrong and the chip blew up something. So you reload the program. All right, you're fine. You're okay. Good. This was machine number 4, let's say. And I look around, I stay around for a while, everything's fine, so I leave, I come back, all of a sudden I get another call, number 2 is down. I said, whoa. So I get out there, I look, sure enough, 2, same problem, re-enter. So at that point, nobody knew anything, because this is just brand new, they just came off the shelf. And re-enter, I didn't even know what it meant, I just knew that it didn't know what to do. So it eventually ended up, we all understood it was static, but what happened was this girl back then, this goes way back when women wore fancy silk dresses and things like this, silk underwear and all this. I don't know, you may still do that now. I don't know that much about that anymore, but back then they were, high heels and all kinds, even if they worked in a grocery store, that was considered, pretty big shot. So I go back, about 3 or 4 times it went down the same day, and all different machines, and I'm thinking, something's wrong with their wiring, there's some problem in the building. Make a long story short, I find out that this one girl, she was like a doll, she was all dolled up and fancy and everything, leather shoes and high heels and this and that, and she had a nylon rug, that she would bring back and forth from standing there in her fancy high heel shoes so that she would not get her feet sore. I don't know, I guess that was it. And she would go from machine 5 and explode it, and then go down to machine 2 with her little rug and stand on there rubbing around, building up a charge, and all of a sudden she'd hit the either like the on-off button or, something that would allow the discharge, maybe even in the cash drawer, lifting up one of the till flippers or something. I don't know, but somehow it was absorbing that into the ground, which everything's grounded. That's fine, but you have what's called reverse EMF. And I can show you that in our lights experiments too. I'm going to show you that right now because it's all coming back to me. The reverse EMF was what exploded the chips, and I'll show you what happens. Boy, this is making so much sense now. This is the static buildup. The discharge to the device, which would be the computer, the cash register, the calculator, whatever it was. And at that point, it tries to find the quickest way to get to ground, which there'll be a ground wire in there. But watch what happens. And nobody ever realizes, and I don't think anybody still does. The buildup here is so intense that it pushes back against all other particles that are coming this way. There's a zone of concussion here which is absolutely incredible. So we started with a particle that is, let's say, 1 volt, and we have 200 or 300 volts here, and we can see it. There's no question whatsoever. That's an increase in energy. No question. Now, the key that was the thing that was causing my problems was reverse EMF, electromotive. This is electromotive force. Electrons forcing other particles out of the way. Well, when they do, they bounce. There's the bounce. You see that? There is the reverse EMF. This is a little sucker that gave me so much troubles. You see that? Absolutely phenomenal. This stuff is showing up. It's like 40 years later. Because here's what happens. This is a wave shoots back through the system. And then we made all kinds of capacitors and filters and so forth that absorbed all of this energy, and diodes and things that wouldn't allow it to go in reverse, and all kinds of things we did. But anyway, it ended up we got well, obviously they don't explode anymore. You get up, you get static, and I mean, you still get static. But the machines, they used to sell spray and everything else. Spray this so they keep the static down. Yes, it did. They had static mats. They had static wrist gloves. They had all kinds of things because static was an absolute destroyer of the electronics. Anyway, that's a whole thing. But boy, I tell you, I remember that now. That girl with the silk underwear. I mean, I told that story 1,000 times. Okay, so if there is no protons, which there is not, what is it they call in cosmic rays? High energy protons and atomic nuclei. Well, the atomic nuclei are nothing but chunks of electrons that have broken apart and don't have enough electrons in the mass to be stable. So they're flying crazy. It's called nuclear radiation, and it's caused by nuclear decay. And what that means is the nucleus is a big ball of electrons. It's like this. It's a huge ball of electrons in the nucleus. And all they are is pluses and minuses. And they hold electrons in their outer orbit that want to get into the dark matter that's in the center. The dark matter is the muons. Okay, the muon part is the dark matter. That attracts the electrons. The dark matter ends up going into the center and coated by the electrons. That means some other electrons want to come in and try to hang around to get into that dark matter, but the electron part here that surrounds the dark matter says, no, we have enough down here. You stay out here at 5 angstroms, whatever it is. And that's what happens, and that's what nuclear decay is, when pieces of chunks like that. Usually light is just like that. Light is like just like that. It's 2 little bits. But when you get a chunk like this, that baby there will kill you. That's nuclear decay. That's where it's supposed to be one big ball like that, it's split into chunks. That's what the cosmic radiation is. All right, they're saying, well, could it be a new kind of a particle? Could it be this? Could it be that? Supersymmetric? What it is there's a gigantic, what's called atomic shock. And I'll explain that in a minute. And when that happens, you get pulses that emit of chunks of material and create enormously bright lights and particles emitting. If I'm right, which I believe I am, we will see more and more of these atomic shocks. What this is there's a layer of surface that coats the entire planet. And below that there's a vascular network of sinkholes, literally, that have a specific purpose on the Earth. I'll speak about that later. But these sinkholes have now been drained of their fluids and gases and oils and methanes and all that, and they have sunk down. So now, way down below is where the layer is, and in this layer there's atomic gases, hydrogen, methanes, hydrocarbons. CH3, all that stuff. And what happens, those are atomic gases. Those are down in the atomic hydrogen area. When they collapse, and this collapses and crushes those particles so closely together, they create atomic shock. And what that means is it shocks the first time, and then they start to explode internally, and they shock the rest of the stuff, and they make an enormous, unbelievable pulse of energy straight up through this tube. That's what they're finding, I believe, because that will create this cosmic radiation, no question whatsoever. The pulses that come out of here will be nuclear particles, they will be a light, they will be electrons, they will be every bit of particles that will come out, and there'll be brilliant white light come out of there. And that is what they're picking up as these cosmic rays. That's my opinion. And this is why I make this statement. You see this? This is a water spout. And what will that do? It creates a different pressure on the surface. And that created this shock. Because I believe what it did was it forced the layer here, which is under the water, to actually drop and crash. And the same thing's happening down in Antarctica. It's going to be happening up in the North Pole and all of these areas where the surface was pretty stable at one time. They've taken so much stuff out of the underneath of it, they're just going to collapse. When they do, the gases that are in there are going to be crushed into such a crush that they will emit all of their energy particles straight up through that tube. Same thing that happened here. Look at that. That is the most intense amount of energy that you could ever imagine. And that's happened in the same situation where you have a lot of pressure variance between the surface and the atmosphere. And then she drops. And this is in Florida. They have sinkholes coming out of your earlobes down there. And it's everywhere around the world now. And I worked with the Russians 5-6 years ago. They got terrible problems there too. Everybody does. It's not restricted to anybody. And I sent them a letter 5 years ago. I said, we are all family now. Russians, Chinese, Japanese, I don't care who you are. We are all family because of this. And if we don't do something about the atmosphere and about our climate, it's all over. Our kids will never see a natural death.